Hey everybody, time for more triangle talk. Okay, today we are going to look at some triangles, specifically the sides and the angles, and we're going to be looking for a relationship in a triangle that we can use for triangles where we don't have as much information. So if you look on this screen, you have two triangles, and on both of them, we are given all three side lengths, and we are given all three angles. And what we want to do is we want to color code them. I'm going to choose a color for my smallest angle. Let's do the smallest angle. Well, maybe I should just go with those colors up there. Let's do the smallest angle in red since this is labeled in pink. Okay, so my smallest angle and my smallest side. Let's see. My smallest side of these three is this one right here, right? It's 4. The other two are 8 and 9. So that's side BC. So this is my smallest side right here. Okay, my smallest angle, let's see, I've got 28, 62, and 90. So the 28 is going to be my smallest angle, and that's BAC. So BAC, that's got to be this guy down here. All right, so small angle, small side. All right, let's go find our biggest angle, and we'll do that in green since I wrote it in green up here. Okay, my biggest side is side AB at 9 centimeters. So that would be this side. And my biggest angle would be BCA at 90 degrees. So BCA would be this guy down here. Whoops, I just measured a side, not an angle. Sorry about that. This would be my biggest angle. Right? And then last but not least, the other two, therefore, must be the middle, right? So that means this is my middle side and this is my middle angle. Okay, so I want you to take a look at that triangle and see if you notice anything specifically about where the small angle is in relationship to the small side, where the big angle is in relationship to the big side. I want you to see if you can notice any patterns. And then we're going to look at this other one and see if those patterns hold up. Okay, so let's do this one. We'll start with big this time. Biggest side, 675, so that's BC. So here's my biggest side. Oh no, I messed up my color coding already. Goodness. My biggest side. It's really still blue. Green, please. Okay, my biggest side would be 7, so that's BC. Okay, and my biggest angle, 86, 40, and 54, so that would be BAC. If you're having trouble reading these angles, it's always the letter in the middle that's the vertex, and so that's going to tell you where the corner is. Okay. What was the smallest? Red. Okay, so for the smallest side, CA would be 5, so that's this guy. And then the smallest angle is 40, so ABC, so that's this one. Okay, and then of course, last but not least, there's only one side and one angle left, so this must be my medium side at 6, and this must be my medium angle at 54. Okay. All right, so here's what I want you to do. We're going to take a pause. In the question, I want you to tell me what you think. What's your theory here? If I'm looking for the biggest side, where should I look? Or if I'm looking for the smallest angle, where should I look? How are the sides and the angles related here? Okay. Let's test these theories. Okay, if you're looking for some, we're looking for some patterns. In this triangle down here, you will notice we've got labeled a little angle and we've got labeled a big angle, right? This is my littlest angle, this is my biggest angle. That means that that one up there in the upper right-hand corner must be my middle angle, right? So based on Goodness. Based on what we just saw in these other triangles, oh, one moment, my floating head is in the way. That's much better. Okay, so based on what we just saw in those other triangles, we noticed that, hey, if I have an angle in a triangle, and that angle's really big, heck is my mouse? Okay. All right, so my mouse stopped working. All right, so use this one. Get ready, my handwriting's about to get real bad. Okay, if you have a really big angle, then that means that across from it is the really big side. In other words, if you look at a triangle, the wider an angle opens up, the bigger the side across from it's going to be. So hopefully you noticed that in those last two triangles. So if we want to know which the biggest side is, all we have to do is look across from the big angle. So the big angle is here at C, so if we jump across our triangle, there's the biggest side, A, B. Okay. If you want the smallest side, all you have to do is find the smallest angle or the littlest angle, right? So here I have a teeny tiny angle here. This is my littlest one. That means that across from it, since this angle is little, it's not going to be open very much, right? The wider it opens, the bigger the side across it gets. If I have a small angle here, if I go across the triangle, there's going to be my small side right there. So my smallest side here is going to be BC. Okay. So we can tell this when we have some measurements, but what we want to do is we want to write this down as just a whole theorem so that we can apply it, just like we applied the triangle sum theorem. And we said, look, even if I don't know all the angles, I know they all add to 180 degrees, right? We want to be able to do that here as well and say, listen, even if I don't know the measures of the angles and the sides, I can still tell which one's the biggest, which one's the smallest, because I know that this is true, right? The big angle is always going to be across from the big side. The little angle is always going to be across from the little side. All right, so let's write this down. Okay, the largest side of a triangle is always going to be across from the largest angle. So in a triangle, you can find the largest side, you know that across the way from it is the largest angle. And by across, remember, we mean the one that it's not touching. All right, same thing with the smallest. So the smallest side of a triangle is going to be across from the smallest angle. So if you're taking notes, you might want to draw a little picture. Draw a triangle with a whoops, didn't mean to do that. Draw a triangle with a nice big angle in it, right? All right, if this is my big angle, notice this angle's touching this side and this side. So the one across from it, this is my big side. Okay? It's always going to be that way, no matter what the triangle is. Okay, so it says if two sides of a triangle are the same, like in an isosceles triangle, then the angles across from them will also be the same. This is not a new theorem, right? We've known this. We know that in an isosceles triangle, if you have two sides that are the same, then you have two angles that are the same. Back in the day, you know, a week ago, we called this like an isosceles triangle theorem, right? And now, here we go. We're now calling it, it's also just kind of part of what we call the triangle inequality. Inequality meaning there's some greater than and less than stuff kicking around. Okay. If all three sides of a triangle are the same, then guess what? All three angles have to be the same. What? My goodness, I'm on fire today with my mouse stuff. What's going on? Okay, then all three angles have to be the same, right? Remember what we talked about. If I've got an equilateral triangle, same, then I know all the angles have to be the same. In other words, they have to be 60, 60, and 60. We already knew that, but it's an extension of this new idea that we have. Okay. And then last but not least, if you have a scalene triangle, I'm really bad at drawing scalene triangles. All my triangles end up looking isosceles. It doesn't matter how hard I try. They all end up looking isosceles. Okay. If you have a scalene triangle, that means you have 3 different side lengths. And if you have 3 different side lengths, then you have 3 different angles. All right. So we're going to take a look at how this can help us solve some problems here. So make sure you have this written down. All right. Okay. So in this particular diagram, we are given 3 side lengths. We are given no angles. All right, but we're going to use the sides to get some information about the angles. So let's list our sides from biggest to smallest. Go ahead and list them. Okay, so my biggest side is this 26, right? That's side BC. Next is this 24, which is side AB. BA also works. And then last but not least, the littlest side here is AC, which is 22. Okay. Now, because I know my biggest side, I can now go to the triangle and find my biggest angle. I have no idea what the measures of these are, other than that they add up to 180, right? But I know something about them. I've got 3 different side lengths, so I know all 3 of these angles must be different. Right? And I know the biggest one has to be across from the biggest side, or side BC. So here's side BC, right? So this angle's touching it, and this angle's touching it. That's not the one we want. The one across from it, this angle right here, that's got to be my biggest angle, because it's across from my biggest side. Okay, let's go find our medium angle. It must be across from side AB. So here's side AB. Let's jump across the triangle from AB. There's my medium angle, angle C. And then last but not least, AC is my smallest side. Here it is down here. Let's jump across the triangle, and there's my smallest angle up there, angle B. So I don't exactly know how big they are, but I know which one's the biggest, I know which one's the smallest, and in the end I know that they add up to 180 degrees. All right, that's what our triangle inequality does for us. We can work it the other way as well. We can go from angles and learn about the sides. Okay, now here they were a little bit tricky. They gave us 2 of the angles, but they didn't give us the 3rd. Good news that we can figure it out, right? If I take 71 and 42 and add them up, that's 113. So I can figure out what that top angle is. So that would be, what, 67. All right, so I now know my big angle, my medium angle, and my little angle. So let's go over here and list our angles. Based on the information they gave us, my biggest angle is angle C, my medium angle is angle A at 67, and my littlest angle at 42 is B. Now, based on this, I can rank my sides, biggest to smallest. I don't have to guess. I know that the biggest side is going to be across from angle C. So here's angle C. Let's go across the triangle. There's my big side, right there, AB. Angle A is my middle, right? Here's angle A, across the triangle. There's my middle side, CB. And last but not least, angle B is my littlest one. So we go across the triangle, and AC has to be my smallest side. So again, I don't know how big they are, but I know this is their order as far as their length. AB has to be the biggest, AC has to be the smallest. So for example, if you tell me that AB is 10 and AC is 6, I don't know how big CB is, but I know it's somewhere between 6 and 10. Right, so it helps me to narrow it down. Okay. Hey, speaking of which, haha, this is why we call it the triangle inequality. So they give us some information here in this triangle. And they want us, the thing we don't have is side AB. Now, I do not have the ability to figure out exactly how long AB is, but we should be able to approximate it. Okay, and we're going to do that by figuring out if it's our smallest, our largest, or our middle. Okay, so let's check this out. I've got 3 angles, right? I've got a 40-degree angle, We have a 79-degree angle, 61-degree angle. Okay, so 79 is my big angle, which means jump across here. This is my big side. That is the biggest side. So I know one thing. The side I'm looking for can't be more than 12 because this is my big angle, therefore this is my biggest side. Okay, 61 is my medium angle, so across, this is my middle guy. And this side is the side we don't know. Okay, but we know it's less than 12. And then last but not least, I have this 40-degree angle, so if we go across the triangle, we find that this 8 centimeters is the little angle. Okay, so look, if I listed these sides, BC is my big side, it's 12. AB is my middle side, I don't know how big it is. And CA is my little side at 8. So, look, do I know how big AB is? No, I do not, right? But I know it has to be somewhere between 8 and 12. It has to be, because the smallest angle is going to be across from the smallest side. I know this is my smallest angle, so I know this 8 is my smallest side. And the biggest angle has to be across from the biggest side. I know for a fact this is my biggest angle, so I know for a fact this has to be my biggest side. So AB has to be somewhere between 8 and 12. It could be 9, it could be 10, it could be 11. It could be 11.2. It could be 11.9 for all we know, but it can't be 12. And it can't be as little as 8. It's got to be somewhere in between. We call that the triangle inequality. See what we're talking about an inequality? It's between here and here. Okay, let's see about another one here. All right. Ooh, this one says the side length of AB must be exactly. So apparently they think we're going to be able to figure out exact side length here. All right, well, I'm missing a side length, so let's go for our angles first. Okay. I've got a 47-degree angle, an 86-degree angle, and a 47-degree angle. All right, so let's list our angles. Angle A is my big angle, and then angles B and C are the same. Right, these are equal. Uh-oh. I've got equal sides. I've got an isosceles triangle. I'm sorry, these are angles. I've got equal angles. I have an isosceles triangle. All right, so my largest side must be across from angle A. And angle A, okay, so my largest side must be BC at 12. Okay, the other two, it's a tie. You can either say it's a tie for smallest, or you can say it's a tie for the middle. I say it's a tie for the smallest. Okay, so let's see. Angle B, if I jump across, that's a 9. And so here's what I know. If angle B and angle C are equal, then guess what? The sides across from them have to be equal as well. So AB has to be 9. Can't be anything else. All right, so put any questions that you have on this first part of triangle inequality in the end note here. And then head over to Schoology to try a few triangle inequality problems. We'll see you soon.